Hello, my name is Kjetil Hindar. I'm a researcher from the Norwegian Institute for Nature Research in Norway. I will give a talk on the re-establishment of Atlantic salmon populations, and I will put emphasis on lessons from Norway. Here is an overview of my talk. I'll first talk a little about the status of Atlantic salmon worldwide and in Norway, and then look at some of the causes for its decline and how to meet some of those threats that reduce Atlantic salmon populations and reduce their numbers. I will then go on to how Norway use cultivation together with other methods to meet some of the threats. I will talk a little about hydropower dams and how we are working in Norway to help fish past those dams. And then I will talk a little about some overarching measures in Norway, the latest being legislation emanating from the Norwegian Biodiversity Act, which is a quality standard for Atlantic salmon populations. Today, I think the last figures is that Norway holds 20% of the world's total number of wild Atlantic salmon. Atlantic salmon are extinct from many areas, and they are declining in many areas, and they are even declining in Norway. When we look at a sort of a world picture where WWF 20 years ago tried to interview salmon managers from all over the salmon range to get a picture of the status of each river in those countries. It became evident that the best status, which is black on this map, is Iceland. A relatively good status was also found in Scotland and Norway. And then there were countries that had extremely poor status, like the big rivers, for example, in continental Europe. And you can see on the map that Czechia is not even colored, even though salmon can migrate to tributaries of the Elbe in Czechia. When we look at the map or the trend in Norway, on the y-axis is an estimate of the number of Atlantic salmon migrating to the Norwegian coast for spawning. And in blue are those captured in sea fishery from 1983 until today. In red are those captured in river fishery. And in green are the estimates of the number of salmon on spawning grounds in rivers in Norway. And you can see that there is the total number of fish has declined by more than 50%. It was more than 1 million fish approaching the Norwegian coast in mid-1980s. And the last few years, the number has been around 500,000 fish. But when you look at the green curve or the numbers on the spawning grounds, they are now higher than what they used to be in most of the 80s and the 90s. And this is because a strong reduction in the number of Atlantic salmon being caught in fisheries. First of all, the sea fishery has been strongly reduced. And secondly, the river fishery has also been reduced. When we look at the causes of decline, I think in all of the distribution area of Atlantic salmon, dam building and habitat alteration, for example, in relation to agriculture or towns, cities, and so on. That is an important reason for why salmon have been lost or reduced in numbers. Also, pollution is historically a very big cause. In Norway, it was long-distance pollution, acidification, which was more important than local pollution. In many other countries, local industrial or domestic pollution is probably a more important factor. In Norway, we have had a big problem with an introduced ectoparasite from the Baltic. It came to Norway with eggs and also smolt, the out-migrating life stage, to Norwegian rivers or to the Norwegian coast. And it is a freshwater parasite, but especially when it came to a few facilities that were meant to develop a salmon stock that could be used for aquaculture. The effect of this parasite was not known, and fry were released from this central hatchery to many of the rivers in Norway. And Gyrodactylus is a parasite that kills a large proportion of the juveniles of Atlantic salmon in rivers. And I will come back to that, how that is. Then there is also a problem, or several problems associated with the enormous success of the aquaculture industry. Salmon are raised in coastal net pens, and the sea louse or the salmon louse, which is a natural parasite, is being produced also on farmed fish in such numbers that it is a threat to both Atlantic salmon and anadromous brown trout and Arctic char. Also, there is a problem with Atlantic salmon escaping from these net pens, and they migrate into rivers, spawn with wild salmon, and cause genetic changes in wild salmon that make them more maladapted to life in the wild. There is a Norwegian advisory committee on Atlantic salmon management, and that is wild Atlantic salmon management. And here to the left, there is a diagram showing how this committee evaluates different threats. The y-axis is an effect axis, which goes from sort of a problem or a threat being a loss factor to high up being a threat to populations. And on the x-axis, there is a development in how this these threats are handled. And when I say handled, it can be by the industry, for example, or that is responsible for this threat, or it can be by the management trying to limit the effects of the threat. So if we look high up to the right in this picture, it is a threat that is expanding, and it is a population threat. And among some of the factors I mentioned, salmon lice and escaped farmed salmon are high up, both on the effect axis and also that it is the development is a problem that is expanding. Also, you can see some other effects that or threats that I talked about. Gyrodactylus salaris, the parasite, is there. And it says that the development is that it is not an expanding problem. Also, acidification and hydropower regulation, they are high up on the effects axis, but they are not very much expanding threats. Also, we see overexploitation, which in Norway at the moment is not viewed as a big problem, except in our biggest salmon river, the Tana, which borders Finland. And the Tana runs in areas with few people and without hydropower and without aquaculture in the neighborhood. So the problems in the Tana is most likely caused by overexploitation. Norway has several methods to meet the threats. One is from early 2000, where around 50 rivers were designated as national salmon rivers, and 29 coastal areas were listed or set aside as national salmon fjords, where, for example, aquaculture was not allowed in these fjord areas. Acidification has been met by liming. The parasite Gyrodactylus salaris has been met by chemical warfare using the poison rotenone to kill almost all life in fresh water, and particularly the parasite and also its host. In the last few years, there have been some development of chemicals that can be lethal to the parasite without being lethal to Atlantic salmon juveniles. And acidified aluminum has been, which is a threat to fish, kills the parasite before it starts killing the fish, but it is a quite costly and difficult method. More recently, there is development using chlorine, weak concentrations of chlorine, less additional chlorine than in drinking water, will kill the parasite without killing the fish. Fishways have been built where there are dams that stop fish migration. Habitat restoration is not very much developed in Norway, maybe because Norway still has quite some numbers of pristine rivers. I talked about reduction of harvests, and I will talk more about cultivation, which is used for supplementation of populations, and in recent time more to maintain populations. And I will go more into the use of live gene banks in Norway. A frozen gene bank means that in Norway we have frozen sperm from Atlantic salmon from many rivers. The knowledge that you could do artificial reproduction of salmonids is 250 years old, and it was 100 years later developed into a method that was used in many rivers to supplement populations and increase populations, stripping sperm and eggs from adults, maintaining the fertilized eggs in fresh water during winter, and releasing first unfed fry, then fed fry, then overwintering in juveniles, and from the 1950s, smolts that could be released in the river or outside the river. In very recent years, the mortality of Atlantic salmon at sea, many places in the world, is quite low. And in Canada, they have started looking at whether it's possible to collect smolts migrating out of the stream, smolts in freshwater tanks on land, and then releasing the fish as adults into the river when they have grown to the common size of spawners. It's sort of a reversed strategy relative to that used in most years since the 1850s. In Norway, we have another strategy that I would call egg-to-egg or gene bank-based cultivation, which is a collection of fish maintained in freshwater throughout the life cycle, and maybe for more than one generation, and then released back into the river where the spawners were taken as eggs one or more generations later. Here is a map of Norway, or of southern Norway, showing that more than 20 rivers have been or are subject to liming, which is a strategy that sort of compensates or attacks the acidified status, which is a threat to both Atlantic salmon and brown trout, the juveniles. In the curves or in the diagrams to the left, you can see the x-axis years after liming, and on the y-axis density of juveniles per 100 square meters. And both the fry or juveniles or the par, later stages juveniles, show a higher density some years after liming. And this is both shown for rivers that had reduced density by acidification and for rivers that had lost stocks because of acidification. Here is a comparison, the same type of diagram, but here the black dots are rivers with stocking, and the open circles are rivers without stocking. And without stocking, you see that the populations recover after liming, but the recovery is slightly faster if the river is being stocked. So the live gene bank. The live gene bank is used firstly to maintain or to rescue populations that where the juveniles were attacked by the parasite Gyrodactylus salaris, because the mortality was so high that these populations would have gone extinct if nothing, or would be in risk of going extinct if nothing was done. So broodstock fish are collected, and also this method is used in rivers which have a high number of escaped farmed salmon, or also a high mortality caused by sea lice. Scale samples are taken from the broodfish, and they are checked to make certain that the scale is from a wild fish and not from an escaped farmed salmon. Also, a genetic analysis is used from DNA extracted from the scales. And this genetic analysis can tell whether a fish has a wild ancestry or whether it can be an offspring in the wild of escaped farmed salmon. If it is genetically similar to a farmed salmon, the fish is discarded. At the same time, there is an disease agent analysis from the body fluid of the broodfish, where it's possible to detect bacteria or viruses that would be harmful in a hatchery. The broodfish is then maintained on a family basis until they are big enough, or the offspring is reared in family groups until they are big enough to be pit tagged, and then they are reared in captivity in freshwater tanks all along to the spawning stage. And the strategy is that fertilized eggs go into the live gene bank, and eyed eggs that can be treated and also with parents checked for disease agents. Eyed eggs go out again and into the river, where hopefully the threat has been eliminated. Then a little about hydropower dams. The fish ladders, that also is a technology that is 150 years old. We know that they now function well for the upstream migration of salmonids, but they are not well designed for many other species that live in rivers. Downstream migration is still a major challenge in many rivers, because some of the turbines that are used for hydropower, they will cut, or all of them will cut big fish in pieces. Some of them will let smolts migrate through, but with huge problems to mortality and also physiological fitness. It's possible to fence the turbine intakes or the water intakes and then lead fish to escape routes downstream. But these fences need to be quite fine meshed, and in big rivers they are extremely difficult to maintain. So there is a project in Norway called SafePass. They have found that it is technically possible to lead fish to a place where the fish can sort of escape downstream. But this needs good understanding of how fish will move in relation to how water moves. So you need to know or understand the hydraulics in all of the technical facilities that you build to lead fish into or to make fish choose the best route downstream. But this is ongoing research and is giving some interesting results. Also, there has been an initiative in Norway looking at regulated rivers with the question if it's possible to increase the number of fish while increasing or maintaining the electricity or the hydropower generated. And then the researchers have made a diagrammatic sketch of the whole year, looking at water needs for egg and juvenile survival during winter. Then the water need is not very high. Then there is a high water need during smolt out migration, maybe also to make flows that will flush the riverbed for fine-grained material, and maybe also be attractive for up-migrating fish. You have periods where juvenile growth and juvenile habitat is important, and it's also possible to design freshets, small flows for attracting fish to migrate upstream to spawning areas. And then the water flow during spawning needs to be constructed or designed so that the spawning redds are available and that they do not freeze during winter. This, I will not dwell on this, but this is a dam built for reducing the stretch that Atlantic salmon use in River Driva in Norway, and also by reducing the salmon, you also reduce the distribution of the parasite Gyrodactylus salaris. This dam, which stops all up-migrating fish, the fish can be sorted into sea trout or anadromous brown trout, which are released upstream of the dam, and salmon are stopped, but their offspring are maintained in a gin bank. This dam will be there for maybe 7 years, and then only the 25% of the river downstream of this dam will be used for chemical treatment. The dam is constructed so that fish can easily move downstream, but they cannot move upstream. The quality standard for Atlantic salmon in Norway, developed from the Biodiversity Act, means that salmon populations are evaluated along 2 axes. They are evaluated population by population, and the first theme is a qualitative one, maintaining genetic integrity, and we are performing genetic analysis to classify each salmon population in relation to how much it is affected by escaped farmed salmon, and how much today's wild salmon resemble the genetic composition of salmon in the river before aquaculture. Also, there is a quantitative ambition that the number of spawners should meet the spawning target, meaning that there should be enough eggs being laid in the river to produce the number of smolts that the river can theoretically or produce. And also that there should be a natural harvestable surplus, meaning that there should be more spawners back than the number of spawners needed for putting out the best number of smolts. This is it. Thank you for your attention.